First of all, what I've done is I've drawn the two spheres, A and B, A with mass 4 kilograms, B with mass m kilograms. We're told that they're approaching one another. A is initially approaching B with a speed of 5 meters per second, and B is approaching A with a speed of 3 meters per second. And after the collision, A moves with a speed of 1 meter per second in the same original direction. Now, in the first part then we've got to find the impulse exerted on A in the collision. So what I'll do is I'll mark in an impulse arrow acting on A, and it acts towards the left. Okay, now what do we know about impulse? Well, you should know that impulse I is equal to the change in momentum. Momentum is mass times velocity, so it's the change in momentum, so it's m times the final velocity minus m times the initial velocity. So you've got to remember that equation. Now it's very important in questions like this that you select a plus direction, and it's always a good idea to select the plus direction in the direction of the impulse. So I'm going to select plus to the left. So if we use this equation, we can see that the impulse I is equal to the mass, which we're considering A, so the mass is 4, times the final velocity V. Now the final velocity, well, we've got a 1 here, but notice that it acts to the right in the opposite sense to the arrow, so that's going to be minus 1. Then we've got minus, and then we've got the mass, which is 4, times the initial velocity, u. And again we see that the initial velocity is 5 units, 5 meters per second, to the right, which is in the opposite sense to this arrow, so that's going to be minus 5. So always take care with questions like this. Okay, so all you need to do now is tidy this up. You've got minus 4 plus 20, and minus 4 plus 20 is going to give 16, and the units are Newton seconds. So that's our impulse. And that brings us now to the end of the first part of this question.